In this module, we're going to learn about the most complex form of data we've covered so far. But what you're going to see, and this shouldn't be a big surprise by now, is because of the way we have thinking about data in terms of type comments and templates and some other ideas we have, we'll be able to learn this much more complicated form of data than ever before, pretty easily actually. So here's a motivating problem. It comes from a very old computer game called Zork. Of course, there's more modern games that are like this. Imagine that you're suddenly transported into a mysterious house or maybe some underground caverns or stuff. And we kind of want to, think about that underground space. So in the simplest case, there might just be a single room, which I suppose if we were doing some kind of game would have some incredible name, but because it fits on the screen better, let's just call this room A. So that would be kind of the simplest underground terrain. It's not very interesting. Now this room might have an exit that leads to some other room, B. And we could draw that this way. And because it's an arrow rather than a line, what this is saying is that you can go from A to B, but you can't go back. Here's another arrangement where you can go from A to B or A to D, but you can't go back. Now all of these so far have actually been kinds of trees, kinds of arbitrary arity trees. We've seen this kind of structure before. But a set of underground passages that you can never kind of get back to where you started is going to be kind of maybe not interesting. So let's imagine going back to our A to B, that you could now do something else, which is that there's a door from B to A. Once there's a door from B to A, there's a cycle in this arrangement. And in fact, what we call this structure is a graph. Okay? There's two ways in which a graph can differ from an arbitrary arity tree, and one is that it can have cycles. We'll see another in just a second. Here's another graph with A, B, and C, and this is showing that the cycles can be arbitrarily long. And finally, here's one more complicated graph showing both cycles. There's a cycle from B to C, back and forth, around that loop. And there's a cycle of A, D, E, A, and around that loop. And this graph also has the other key property that makes graphs different from arbitrary arity trees, which is that there's two arrows leading into E. So in a graph, in general, there can be more than one arrow. There can be 0 or more arrows leading in to a given node in the graph. And in a graph, in general, there can also be cycles. Although there is this fancy word called an acyclic graph, which is a graph without cycles. So that would be a graph that would have more than one arrow leading into some node, but it wouldn't have any cycles. What we're going to look at for the rest of this week is the general form of graphs in which they are directed, meaning the arrows have one point on them. You can only go one way down an arrow. And they're cyclic, meaning there can be cycles. So that's a whole new form of information that we've never seen before. It's this idea of a graph. From here on in, we're going to see that it's stuff we've learned before and that we've got a powerful platform for designing functions that operate on such graphs.